Hello, everybody. My name is Camille Campbell, and I'm with Extreme's Product Marketing Organization. I'm very pleased to welcome you to this on-demand webinar where you'll get an overview of our Fabric Connect technology, how it is unique in the industry, and how it can be used to simplify, scale, and provide better resiliency to video surveillance networks. So before we dive into it, I just wanted to provide some background on this technology for video surveillance. We've been providing infrastructure solutions for video surveillance networks for approximately 6 years now. Therefore, we have literally hundreds of thousands of IP cameras running over our networking gear today. Our strongest segment has been gaming, and we have a very large presence in both Las Vegas as well as Macau, China. In addition to gaming, we've been strong in government, transportation, education, manufacturing, and hospitality. One of the nice things about our technology is that it can support even the smallest video surveillance implementation up to the very large. And the largest implementation that I'm personally aware of is 40,000 IP cameras that are deployed in one of our casinos. Making this even more impressive is the fact that this is a full multicast deployment. And we're going to get into multicast in a little bit. We've done high-profile events like the 2014 Olympic Winter Games, and we've even supported a transit authority in a major city when they had to rapidly scale their video surveillance network to prepare for the Super Bowl. We've also worked with many of the large IP for surveillance camera and VMS vendors, so Pelco, Access, Genetec, Panasonic, Samsung, just to name a few. And we've been successful because we really recognize what our customers are looking for in a video surveillance solution. Recording and archiving the video without any loss, without any glitches. Responsiveness to any incidences by being able to pull up the needed video surveillance streams without any delay. The quality and availability of the video, not having any choppiness or blurriness. The ability to easily add new cameras or new viewing stations to the network without a lot of heavy provisioning, really having simplicity in deployment. And what we're seeing more and more of is this demand for AI ML driven software that can use image recognition to recognize faces, objects, events, and more from both the live streamed as well as the recorded video. So what we see is that often an underestimated component of having a high quality video surveillance network is the underlying network itself. And in a report from ZK Research, when he went out and talked to security integrators about their challenges with IP video surveillance operations, it was estimated that 70% of the common problems with video surveillance, so things like blurry video, delays in pulling up footage, could really be attributed to the underlying network. And just to give you an example of one such customer having major headaches with their surveillance solution is a law enforcement customer that we have in Michigan. They were having massive problems with their video surveillance system. Cameras dropping off the network, encoders locking up, and this was a huge problem since the surveillance network was integral to assisting their lean law enforcement team in really doing their job. You can see the customer had mentioned it was completely unacceptable. On top of that, they had a real need to expand their current surveillance network and attach more cameras in more locations, but the underlying network was so stable and so complex that they needed a better solution. So many of the reasons that this particular customer and other customers that we work with have problems with their surveillance system is because the network technologies are aging. Networks are being designed and built with the same technologies that have been in place for the last couple of decades. Most people don't realize that OSPF, arguably the most common protocol we have in networking today, was standardized in 1991. Back then, networks were designed for simple workflows like connecting users to the internet. Today, we have a much more dynamic and mobile networking environment with demanding applications like video surveillance, which warrant low latency, high bandwidth, fast resiliency, and better scaling. We need a new way to design networks. And the challenge with today's networks is that they are complex, they're inflexible, and they're vulnerable to change. And if you think of where video surveillance is going with more sophisticated cameras and AI ML driven analytics, we really need to think about how we build networks to make them less complex, easier to manage, and a lot more plug and play. So our Fabric Connect technology is based on a next generation protocol called shortest path bridging. It was designed to simplify networking and bring it up to date so that it is more flexible, more agile, and better equipped to support today's modern applications like video surveillance. The shortest path bridging standard is a technology which has its heritage in the service provider space. So this gives it a lot of its inherent security properties and segmentation capabilities, which we're going to talk about later. And its goal when it was developed was really to deliver the functionality of established carrier protocols like MPLS, but get rid of all the operational complexity that comes with MPLS, so that it can be easily deployed cost effectively in both large as well as small networks. And really what it is a network virtualization technology. So in the same way server virtualization allowed multiple applications to run on the same physical server, Fabric Connect separates the services from the underlying Fabric infrastructure. So there's far more agility in deploying or changing network services. It really enables multiple isolated, secure virtual networks to run as ships in the night over a single physical network. These virtualized networks are inherently secure and can be set up and changed very quickly with edge provisioning only, eliminating instability and risk of error. It essentially brings a level of agility and flexibility to the network that just hasn't been possible with traditional networking. So getting into the technology a little bit deeper, the data plane, how we forward traffic, is based on Ethernet switch paths. In addition to that, the standard also defines a new construct called an Ethernet ISID. So this is basically our service abstraction layer. It's the network virtualization component to this technology. And what it allows you to do is to map any type of service at the edge, whether it be a VLAN or a layer 3 VRF. And then the ISID dynamically interconnects those services without needing to provision anything in the aggregation or network core. And we'll get into a few more details later in the deck. The control plane is based on ISIS routing, which has been operating in carrier networks for many, many years. So the idea is you get rid of the challenging parts of Ethernet. You get rid of the need to block ports, you get rid of flooding and learning, and as a result, you make Ethernet much more scalable and reliable by using a carrier-grade multi-service routing protocol as the control plane. And when customers have deployed this networking technology, we find it has a dramatic impact on their applications and how those applications function without needing to change the video surveillance setup. So just by changing the underlying network, the video surveillance system at our law enforcement company went from being unreliable and complex to absolutely flawless. And some of the notable benefits were the ability to assess situations requiring rapid response, the abilities to scale and add cameras where needed as quickly as possible. And when we checked in with this customer months post-deployment, they reported virtually no maintenance required for their now rock-solid, always available network. With video surveillance over the past 10 years, we've seen a major shift occur, and that shift was analog to digital video. What we're also seeing is a shift in the digital world from a networking perspective, from using unicast routing to multicast routing. And the reason why things are going to multicast routing is because a single video stream from a single camera must go to multiple destinations, multiple viewing stations, recorders. And now with AI/ML-based analytics, those streams may even have to go up to the cloud. So when you have a single stream going to multiple destinations, the most bandwidth efficient way to design the underlying network is using IP multicast. However, there are problems with this transition to multicast routing. Traditional multicast is based on old, complicated protocols like PIM. And if you remember back on that slide, multicast first originated back in 1986, so it's old. PIM and other traditional multicast protocols were really designed for scenarios where you have one source with many destinations, like IPTV or desktop imaging. The problem with IP surveillance is you have hundreds or even thousands of sources, your IP cameras, but then fewer destinations, your viewing stations. And this is because when you get this reverse model, traditional multicast really starts to break down when you start building larger networks. Multicast is also notoriously complex. It is very difficult to design, very complicated to deploy, and very painful to troubleshoot. One of the biggest issues of all is if there's a network failure, the multicast service is slow to reconverge. Minutes are not uncommon. And then this of course impacts the video quality, creates lapses in the video, and of course can impact scale. Therefore, we see many implementations wanting to stay at unicast routing, even though it lacks efficiency and creates far more traffic on the network, because they're scared of the complexity that comes with multicast routing. So the basic reason why our technology is so strong for IP multicast applications is because we support highly scalable, high performance multicast without the need for any complex multicast protocols. And just to back up a little, what makes our Fabric Connect technology so unique is the simplicity that it brings. So the traditional way of building enterprise networks with layer 2 at the edge and routing in the core requires a number of control planes and a number of protocols, each with its own design rules, configuration requirements, and interdependencies. And one of the biggest interdependencies comes with a network failure. So if there's a failure, each layer has to wait for the one below before it can reestablish. So therefore, protocols higher in the stack, like PIM multicast, has to wait for OSPF to reconverge before it can reestablish. And that's why for large networks, it's not uncommon for a multicast network to take a minute or more to reconverge, which can obviously have a very negative impact on the quality and the availability of the application. So what Fabric Connect is it's a new way to design and build networks, when rather than using all of these different protocols, there's just one. So it supports your traditional services, your layer 2 services, your unicast and multicast routing, and even VRFs. But it only requires one control plane, one protocol. And this obviously has a huge impact on how networks are operated. A single protocol makes the network much faster to deploy. It provides increased stability because you're eliminating that interdependency between protocols. You have much more intuitive troubleshooting, and you get much faster resiliency. And when looking at an application like video surveillance, based on third-party tests, we've seen milliseconds versus minutes. Another way Fabric Connect simplifies the network is by reducing touch points. So today, if you want to change the location of an IP camera, or add a new IP camera, or move a VMS, you have to provision all the routers in its path. And having too many touch points is not only time consuming, it's also vulnerable to human error. With Fabric Connect, there's a level of automation that's built directly into the technology. What this means is that when adding new cameras or changing the locations of cameras, those changes or services are completed at the edges of the network only, and then propagated throughout the aggregation and core dynamically. So your aggregation and core nodes are not touched. So this has a huge impact, not only on the stability of the network, but also on the agility, how fast you can actually do your moves, adds, and changes. So I wanted to provide another customer example, And one that I think really illustrates the complexity of multicast is Indiana Department of Transportation. So as you would expect, they had a very large video surveillance network to help keep traffic moving and to be able to alert drivers if there was an incident or an accident. The problem really stemmed from their network and its inability to remain stable with this very large video deployment. The stability was very much related to the complexity of running IP multicast. And it got so bad that this customer told me 45% of his work week was dedicated to solely troubleshooting multicast issues. And unfortunately, due to this complexity, network outages took lots of time, weeks even, to troubleshooting. Now, after evolving to Fabric Connect, they spend exactly 0% of their day troubleshooting multicast. They have dramatically improved the stability and reliability of their deployment. Video quality was enhanced, performance improved, and the network was a magnitude easier to implement and support. And you can see by the quote, with their old multicast deployment, to troubleshoot a failed link would take a full day, but now it's no big deal. One of the challenges that we solve with Fabric Connect is also related to security. And I have read in various analyst reports that it takes only 3 minutes for a malicious actor to hack into an IP surveillance camera. I mean, you can even Google it, and there's plenty of videos out there showing you how to do it and how easy it is. We also saw the largest DOS attack ever recorded that brought down websites of massive corporations. And this attack was carried out by a botnet of personal devices. So not only IP cameras, but also home routers and even connected baby monitors. So what Fabric Connect does is it segments the network into small, completely isolated private networks. So you can ensure video surveillance traffic is completely isolated from other traffic in the network. Or you can segment different cameras into different network segments to really reduce the potential attack surface. Once we see, often we see video surveillance and other physical security technologies like door readers or alarm systems. We see them typically deployed on separate physical networks. But with Fabric Connect, we've been able to prove time and time again through the inherent security of our technology that we can completely and safely isolate that video surveillance traffic over a converged infrastructure. So on a traditional network, the most common approach to segmenting the network is putting different devices in different VLANs and then controlling access to those VLANs through ACLs. This is operationally very complex, and protection is also weak because the routing table isn't segmented, meaning the network itself is flat, and therefore the ability to discover the network topology and move through the network can be more easily accomplished. What Fabric Connect does is gets rid of flat networks, and it fully segments the routing table using VRFs. And it also allows for large numbers of network segments to be created with ease and at scale. These segments are circuit-like in nature and are completely isolated when provisioned. This ensures that video surveillance can be deployed isolated among other traffic from other IoT devices, or even different user groups or different applications. The other piece that really contributes to the inherent security of the technology is the fact that forwarding is in a Fabric Connect network is based on IP switch paths as opposed to IP. There's no IP forwarding anywhere within the aggregation of OR core. The IP actually resides inside the fabric, but it's only configured at the network edges. All forwarding is done via Ethernet. So what this means is that the common tools that hackers use to discover the network topology do not work in a Fabric Connect environment. This inability to discover the topology through IP scanning tools make it nearly impossible for hackers to scan the topology and use that information to laterally move to more sensitive areas of the network. To further illustrate the strength of having a segmented network, I wanted to talk about a Las Vegas casino. At the time this hotel was being built, the biggest requirement that they had is they wanted a highly secure network environment so that they could segment some of their important applications like gaming, point of sale, back of house, telephony, guest services in their own isolated environments. What's interesting about this deployment is that the video surveillance was originally going to be deployed on a separate physical network. And this was actually mandated by the Nevada Gaming Control Board due to the mission critical nature of the service in the gaming world. Once we were able to show the customer the stealth nature of the Fabric Connect technology and how each application can run in complete isolation of each other and in complete isolation of the core infrastructure, the customer was interested in seeing if they could converge the video surveillance traffic as well onto the network to avoid having to build out that parallel network. And really, this is what led us to being the first converged surveillance network to be approved by the Nevada Gaming Control Board. And it was because we were able to demonstrate the inherent security of our technology and our ability to create a completely isolated environment for video surveillance traffic that led us to being approved. So another strength we have with our technology is our auto attach features, which we call Fabric Attach. And what Fabric Attach does is it enables edge automation by enabling zero-touch user and device attachment to the network. So if you remember with Fabric Connect, you only enable services at the edge. You don't have to reconfigure any of the aggregation or core nodes. Fabric Attach automates those edge touch points, so you have a truly automated zero-touch network. So what exactly it is it's a signaling protocol that uses extensions to IEEE 802.1ab, link layer discovery protocol, to automatically attach network devices or clients into ISIDs or Fabric Connect services. And it is a signaling protocol that is currently being standardized through the IEEE. And there are certain Pelco and access video surveillance cameras that actually support the signaling protocol. And really what this means is it really makes everything plug and play. You plug a camera into the network and it's dynamically assigned not only the right VLAN, but also the right corresponding Fabric Connect service or ISID. And this all happens dynamically. And really one of the benefits or the values that this auto attach feature brings is elasticity. And through a combination of Fabric Attach and Fabric Connect, what this allows you to do is to dynamically establish secure segments at the network edge as authenticated users and IP cameras connect. Segments are elastic in nature and extend and retract as IP surveillance cameras, for example, connect and disconnect from the network. And when an IP camera is disconnected from a switch port and access to the segment is no longer required, what's nice is the residual configuration is automatically deleted on that edge switch. So this not only removes delays and risks associated with manually configured conventional networks, it also eliminates the risk of a backdoor entry point to the network. And it really is a feature, a security feature that customers really appreciate. So another great example of a customer who really saw the value of Fabric Connect for the connectivity of their video surveillance system is the city of Memphis. And the city of Memphis is the headquarter location for FedEx. And because of that, they actually have the world's second largest cargo airport. They also have a very innovative smart city initiative. And so they needed a new, flexible, future-proof network foundation that would be capable of supporting almost 1,000 very sophisticated AI-powered video surveillance cameras. They also wanted in the future to be able to support many of their smart city initiatives, things like intelligent traffic signals, as well as some smart building initiatives like HVACs and intelligent lighting. So in short, they chose Fabric Connect as the right future-proof foundation to power their advanced video surveillance system and to segment that traffic in a secure network completely isolated from some of their other IoT devices, intelligent traffic systems, for example, with a much more automated approach than alternative solutions. We've even been deployed in likely the most mission critical environment you could really think of, a nuclear power plant. And we displaced a major networking vendor in this example. I've called them X on the slide. And the customer was just completely impressed at how we could handle multicast traffic and how quickly we could reroute around any failures without any impact to the video. Hands down, the fast resiliency that we can provide with this technology was the single most important attribute. And the quote is very worth reading because it really speaks to the strength of our products. And in terms of how you could design a network to support video surveillance, there are many options. So what we are showing here is quite a large implementation, but we can also design for small to extremely large as well. We have a series of switches called the VSP 4000, and they're really purpose-built for this exact use case. The VSP 4900 series represents the latest models in these series. So typically you would have a VSP 4900 at the edge connecting the video cameras, and then a small core switch, like one of our VSP 7400 series at the head end location. However, depending on the size of the network, it could also be a 4900 at the core, or it could be a VSP 8000 as well. So the point is, we do have a number of specific products to design whatever network will work best for their specific implementation. And again, it can be unicast, it can be multicast. We can support whatever video surveillance implementation that the customer needs. And this really is a wrap up or a summary of all the things we've essentially covered. But it gives you that side-by-side comparison of why Fabric Connect is so different from traditional networks in the context of video surveillance. So of course, we talked about protocol overlays that are involved with traditional networking and all the interdependencies. With Fabric Connect, it's just that single protocol, your single control plane, which simplifies and streamlines the network. And it eliminates the need for the most complicated protocol there is in networking today, PIM multicast. Traditional IP multicast networks can be painful to deploy. Provisioning rendezvous points, bootstrap routers, configuration throughout the network. With Fabric Connect, all this goes away and it's edge provisioning only, with the added benefit of dynamic auto attach of IP cameras. IP multicast is slow to recover. Fabric Connect is fast because it's only one control plane without any dependencies on underlying protocols beneath it. And this is really, again, I'll mention it again, it's where we see customers' eyes light up when they can see a core link fail without any major glitches to the video stream. And we can do that. We offer massive scaling. I mentioned, tens of thousands of cameras. Typically with multicast, you start running into a few headaches when you get to a couple hundred cameras. Our engineers tell us that supporting 40,000 IP cameras with a traditional multicast network would literally be impossible. And we have it running and we have it stable. Stable performance. One of the challenges with multicast is when there is a significant failure, a significant network event, CPU utilization on the multicast enabled devices can go sky high. We've even had some routers lock up with previous customers that we've worked with. With Fabric, we really eliminate that erratic performance and you won't see any of those CPU massive spikes. And then finally, we offer the ability to isolate video surveillance from other types of traffic on the network, other types of IoT devices, user groups, applications, and provide that completely private and closed network that can be totally isolated. But at the end of the day, what is important is what we deliver to the video surveillance application. And it's really, if we deliver that modern network infrastructure that is very simple and agile and resilient and secure, we can deliver the quality of the video surveillance implementation that the customer is invested in. And really, at the end of the day, that's the most important thing. So with that, I hope you've enjoyed this on-demand webinar. And if you have any questions, my email's on the front of the slide, and please reach out to me at any time. Thank you very much. Bye-bye.